In our earlier video, we had learnt about intermolecular forces and intramolecular forces and had learnt about van der Waals force, that is intermolecular force, in detail. In this video, we'll be learning about dipole-dipole force, that is a type of intermolecular force, in detail. But before that, let's again revise what is an intermolecular force and what is intramolecular forces with the help of water molecules as an example. Say this is a water molecule, so a bond between O and H is called intramolecular force, that is a bond between one atom and the other atom. But what's the intermolecular force? Let's see that this is one molecule of water and this is another molecule of water, and the bond which exists between two such molecules is called intermolecular force. So in this video, we will learn about one such type of intermolecular force, dipole-dipole force. We call it permanent dipole-dipole force because the van der Waals force is called temporary dipole and induced dipole force. Another name of the van der Waals force is London dispersal force. So let's see what is this permanent dipole-dipole force. Let's take an example of two such molecules. Say this is an HCl molecule and we can see a shared pair of electron with this HCl molecule. Suppose this is another HCl molecule or any other polar bond which is again shown by a pair of electron which is shared between these two atoms. Now, as we know that the hydrogen atom is having a very low electronegativity compared to the chlorine atom. So, chlorine is much more electronegative compared to hydrogen. So, chlorine is going to attract this bonding pair of electron towards itself. Because of its high electronegativity, the electrons become unequally distributed between the two atoms and moves towards the more electronegative chlorine atom. And the same thing may happen with the other molecule also, or any other polar bond where a more electronegative atom pulls the bonding pair of electron towards itself. Now, when such molecules are polar with a partial positive and a partial negative charge on its atom, then the bond existing between such polar molecules will be a permanent dipole-dipole force. So, two such molecules which have a permanent dipole on it may get attracted to each other, and such a force which exists between two such molecules is called permanent dipole-dipole force. But these polar bonds are in addition to the basic induced attraction. Basic induced attraction means the van der Waals force which exists between each and every type of molecule. So such an extra attraction which is due to the polarity of the bonds between these dipoles means that there is an extra force of attraction between these molecules. And so we need more energy to separate such molecules. That is, separation of molecules is actually the boiling of that compound. So as higher energy is needed to separate such molecules, the boiling point will also be higher for such molecules for the expected given mass. Now let's learn that with the help of an example. Suppose we have an hydrogen chloride, methane and water molecule with us. Now let's understand the difference in their boiling points, which is minus 85 degrees Celsius for hydrogen chloride, that is HCl molecule, minus 161.5 degrees for a non-polar methane molecule, and plus 100 degrees for water molecule. Now what the example says is, explain the trend in the boiling point of this given compound which are gases. Now let's understand what's the difference between these compounds. Methane is a non-polar molecule. Hydrogen chloride is a polar molecule and water is also again a polar molecule. Now out of these three boiling points, methane have the lowest boiling point of minus 161.5 5 degrees compared to the other two polar molecules, methane and water. So let's understand why is it. From the three molecules, methane is a non-polar molecule. So the only force of intermolecular force of attraction which exists between two such methane molecules, say one methane molecule and the other methane molecule, the only intermolecular force that exists between two such methane molecule is the van der Waals force only, which is very, very weak. So the boiling point of methane molecule is also very low. But for HCl molecule, hydrogen chloride molecule have a permanent dipole-dipole force between its molecules in addition to the temporary dipole, that is the induced dipole or the van der Waals force. So because of this additional permanent dipole-dipole force, it has a higher boiling point. While water molecules are the most polar molecule because it has the highest intermolecular force between its molecules, and so it has the higher boiling point, highest boiling point out of all these three molecules. Now we also need to understand that water is just not a polar molecule, so it just does not have a permanent dipole-dipole force, but in addition to the van der Waals force and permanent dipole-dipole force, it has one more and additional extra intermolecular force which we may learn in the next video. So for now you can understand that the water molecule have the highest intermolecular force, and that's the reason that it has the highest boiling point. The next example says, which of the following molecules have the highest intermolecular forces? The first option is chlorine iodide, that is a molecule contain a chlorine and iodine atoms. The second option is fluorine chloride, that is a molecule contain fluorine and chlorine, and the third option is hydrogen chloride, that is an HCl molecule. Now we know that both these atoms are different and their electronegativity values are also different according to the Pauling scale. So such molecules are going to be polar with more electronegative atom as partial negative and the less electronegative atom as a partial positive atom. So each and every molecule is a polar molecule, but the difference between the two atoms, the difference in the electronegativity between the two atoms is highest in the hydrogen chloride, that is HCl. Hydrogen has the least electronegativity compared to the other molecules. So hydrogen chloride molecule is having the highest intermolecular force, and so the correct option is hydrogen chloride. So in this video we have learned the permanent dipole-dipole force in detail, and we had also learnt about van der Waals force in our earlier video, and in next video we'll be learning about the hydrogen bond, another type of intermolecular force.